Yes, it is possible to place two separate 20-amp, 120-volt receptacles on a single 20-amp, 2-pole breaker and share a neutral. This configuration is often employed in commercial and industrial environments. This is referred to as a multi-wire branch circuit. There are a few crucial aspects to consider when implementing this type of circuit. Firstly, the neutral wire must be appropriately sized to handle the combined load of both circuits. In this specific case, with two 20-amp circuits, the neutral conductor should be at least 12 AWG copper or its equivalent. Using the appropriate gauge is crucial for safety and to prevent overheating. Secondly, ensure proper protection by utilizing a ground fault circuit interrupter, commonly known as a GFCI. A GFCI device is designed to detect even small imbalances in current between the hot and neutral conductors. If an imbalance is detected, indicating a potential ground fault, the GFCI will quickly trip the circuit, cutting off power and preventing electrical shock. Finally, it is essential to clearly label the receptacles to indicate that they are part of a shared circuit. This labeling helps to avoid confusion during maintenance or troubleshooting. A shared neutral circuit, often called a multi-wire branch circuit, can be an efficient way to supply power. It reduces the number of conductors needed and can save on materials. However, it is imperative that it is wired correctly to maintain safety and comply with electrical codes. If the neutral conductor is interrupted while both circuits are energized, it can result in a dangerous overvoltage situation. If one of the circuits has a higher load than the other, the imbalance can lead to excessive voltage on the lower loaded circuit, which can damage equipment. A two-pole breaker ensures that both circuits are disconnected simultaneously, which is critical when working on the wiring. When installing this configuration, follow these steps. Firstly, install a 2-pole 20-amp breaker in the electrical panel. Secondly, run a 12/3 AWG cable from the breaker to the first receptacle box. The 12/3 AWG cable will contain a black wire, a red wire, a white wire which is the neutral, and a green or bare copper wire for grounding. Thirdly, connect the black wire from the cable to one pole of the 2-pole breaker. Fourthly, connect the red wire from the cable to the other pole of the 2-pole breaker. Fifthly, connect the white wire, the neutral, to the neutral bus bar in the electrical panel. Sixthly, connect the green or bare copper wire to the ground bus bar in the electrical panel. Seventhly, at the first receptacle box, connect the black wire to the hot terminal of the first receptacle. Eighthly, connect the white wire to the neutral terminal of the first receptacle. Ninthly, connect the green or bare copper wire to the ground terminal of the first receptacle. Tenthly, run another length of 12/3 AWG cable from the first receptacle box to the second receptacle box. 11thly, at the second receptacle box, connect the red wire to the hot terminal of the second receptacle. 12thly, connect the white wire to the neutral terminal of the second receptacle. 13thly, connect the green or bare copper wire to the ground terminal of the second receptacle. Ensure all connections are secure and properly tightened. After wiring, test the receptacles using a receptacle tester to verify that they are wired correctly and grounded properly. Always consult local electrical codes and regulations. These codes are designed to ensure safe electrical installations and may vary by location. A qualified electrician will be familiar with these local requirements and can ensure that the installation complies with all applicable standards. Working with electricity can be dangerous if not done correctly. If you are not comfortable working with electrical wiring, it is best to hire a qualified electrician to perform the installation. It is also essential to consider the National Electrical Code, or NEC, requirements for multi-wire branch circuits. The NEC provides specific guidelines for the installation of these circuits to ensure safety and prevent hazards. One key aspect of NEC compliance is the proper identification of the neutral conductor. The neutral wire must be clearly identified throughout the circuit. For example, it is sometimes required to mark the neutral conductor with a white or grey color. This ensures that it is easily distinguishable from the hot conductors, even when multiple circuits are present in the same conduit or enclosure. Another important consideration is the proper termination of the neutral conductor, the neutral bus bar in the electrical panel. The neutral conductor must be securely connected to the neutral bus bar, and there should be no loose connections or frayed wires. A loose neutral connection can cause a variety of problems, including voltage fluctuations and equipment damage. In addition to the NEC requirements, it is also important to follow the manufacturer's instructions for any electrical equipment that is being installed. The manufacturer's instructions will provide specific guidance on how to wire the equipment correctly and safely. When working with electrical wiring, always use the proper safety equipment. This includes wearing insulated gloves, safety glasses, and appropriate clothing. It is also important to work in a well-lit area and to avoid distractions. Before starting any electrical work, always turn off the power to the circuit at the breaker panel. Use a voltage tester to verify that the power is off before touching any wires. Never work on live electrical circuits. If you are unsure about any aspect of the electrical installation, it is always best to consult with a qualified electrician. A licensed electrician has the training and experience necessary to perform electrical work safely and correctly. In summary, sharing a neutral for two 20-amp, 120-volt receptacles on a single 20-amp, 2-pole breaker is possible, but it requires careful planning, proper wiring techniques, and compliance with all applicable codes and regulations. A qualified electrician can ensure that the installation is done safely and correctly. A multi-wire branch circuit, when properly installed, can be a safe and efficient method for providing power to multiple loads. Firstly, ensure the neutral conductor is adequately sized for the total load. Secondly, provide ground fault circuit interrupter protection. Thirdly, label the receptacles clearly. By following these guidelines and consulting with a qualified electrician, one can safely and effectively implement a shared neutral circuit. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. If you're not comfortable doing the work yourself, hire a professional.